So for today, we're going to start with the topic traversing principles, specifically, again, traverse adjustment and area computation. Remember, I gave you a homework to define certain terms because those are the terms that we'll use in this topic, namely your latitude and departure. So latitude of a line is simply the projection on the north-south meridian. So over here. While the departure is the projection on the east-west line. So here. So based on this drawing, it's easy to figure out what is latitude and departure. Okay. Now, another way to look at it is latitude is always the vertical component of a line. Departure is always the horizontal component of a line. And then, using that definition, we can create an equation for both latitude and departure. Since latitude, vertical component, and then given this angle here, which is your bearing, you can figure out the value of this using your trigonometric functions, specifically your cosine. So cosine, whatever this angle is, let's call that alpha. So cosine alpha equals adjacent over hypotenuse, adjacent being this line, which is your latitude, over hypotenuse line AB. Therefore, latitude is just that line AB cosine alpha. So this just using your trigo functions. And then similarly, departure is just L sine alpha. Please do remember alpha is the angle from the north-south line. So L, length of the line, alpha, bearing angle. And again, bearing angle is always from the north or south line. Okay? Now we're also going to follow sign conventions. North and east positive, south and west negative. So it's the usual sign convention that we use for things like this. Now, similar to your measurement of distances, there's also errors for your latitude and departure. Now, supposedly, if you compute for the total latitude and departure of a traverse, remember traverse is a closed polygon, summation of both of them should be 0. Okay? And then, if it's not 0, you'll get your error in latitude E sub L and error in departure E sub B. Error in latitude is the resulting error from sum of latitude. Hold on. And then error in departure, resulting error from sum of departure. So for example, if you take summation of latitude, you're going to compute for this, take the sum. It's not 0. Whatever value you get is immediately your error. Same thing here, whatever value you get, if you take the summation of departure, that's your error in departure. And then we have two types of error, your linear error of closure, also known as your LEC, that's just square root of EL squared plus ED squared. Because remember, latitude and departure are just the vertical and horizontal projections of a line, or the X and Y components of a line. So if you want to get the total error or the resultant error, right, that's just using Pythagorean theorem. For example, if you remember from your previous physics, or if you've had mechanics, if we have a lot of vectors, a lot of lines, okay, and then you're going to take the summation of all of the X components and get all the summation of all the Y components. Resultant is just square root of the X component squared plus Y component squared. So it's the same principle here, right? Instead of components, these are errors in latitude and departure. Okay? And then we also have your relative error of closure, REC, or precision, which is just LEC over perimeter, where perimeter is the total sum of the lines composing your traverse. Okay? So let's have an example to better understand what's happening there. So example 1, compute for the latitude, departure, error of closure, and precision of the traverse. All right, so let's do that. Let me just copy this table so that I don't have to rewrite it. All right. Okay. So to get latitude and departure, again, remember the equation L cosine theta, L sine theta. For theta or alpha is your bearing. So both of those are already given. You have your length L and then your bearings theta. And then remember sign convention applies. So let me just extend all of this. Okay. So first, let's try taking your latitude. I'm going to solve for it first. You can follow along with your calculator. I'm not going to take recitation yet so that you have an idea on how to compute for it. Okay, so latitude, going back to our equation, to refresh ourselves, and that's just L cosine alpha. Okay, so just always use L cosine alpha for latitude. So that's 189.53 cosine 6 degrees 15 minutes. And remember, latitude is the vertical component or the projection on the north-south meridian. So if it's south, negative. If it's north, positive. This is south, so that's immediately negative. Again, 189.53 cosine 6 degrees 15 minutes. You should get negative 188 point. And then we're gonna round off to 3 decimal places. And so for your exam, again, I'm gonna say or include in the question to what decimal place you're supposed to round off. So here, let's use 3 decimal places. Next, side BC. So that's again south. So that's negative 175.18 times cosine 2936.58. We should get 152.294. Okay. And then next, this is north. So that's positive 197.78 times cosine 81. That should be 29.949. Okay. And then this is also north, so positive 142.39 times cosine 12. That's 139.069. And then lastly, that's north as well, so positive 234.58 times cosine 42, 59 minutes 23 seconds. That's 171.589. All right. So next, that's latitude. So now I'm gonna ask for departure. Remember, equation for departure is L sine alpha. Departure is along the east-west line. So west is negative, east is positive. When I ask you what is the departure, please include the sign as well in your answers. Okay? So let me just pull up your recitation sheet. There you go. Okay. All right, let's begin. Can anybody give me the departure of line or side AB? Correct. Carlo and Zalika. So Angel first. Again, please round off to 3 decimal places. Right. How about BC? Correct. Gabriel and Jizer de la Cruz Sampan. All right. So again, that's 86.57. Wait lang, let me recompute. Oh yeah. 171.590. Oh, correct. Thank you for the correction. Okay, who was that? Hmm? All right, next, how about CD? Correct. Gabriel. And RDL. So lapid something. It's negative. 195 499. What about B? Correct. Zaira Penoliar and Geraldine Lazaro. Lazaro Penoliar. It's negative 30575. And then, what about EA? Correct. Zaira and Carlo. So then, Penoliar, Philip for the sky. 2, 159. Positive. Okay, so that's the first part. That's how you get latitude departure. Now next, follow-up questions. Error of closure. Again, error of closure. To do that, we have to get first your EL and ED. EL is the resulting summation of your latitude and departure because it's supposed to be 0. So anything other than 0 is an error. Can somebody please compute what is this? Okay, 3 decimal places pa rin. So correct, Denzel and Alexandria. Arendon, Lahore. Okay. Okay. Correct. So negative 0.089. And then someone please get the sum of that. Negative. Correct. Um, 0.99. Correct, Jericho. and RDL. So Lapid Daguno. Okay, good. It's negative 0.184. Okay, please make sure you're getting these answers because even the smallest error in decimals will make our answer incorrect. Okay, then we're not done. What we're looking for is error in closure. So that's LEC. And remember, LEC is just EL squared plus ED squared. And this is your EL, this is your ED. Using that, please compute what's LEC. Correct. Zelica and Maro. Kasople, Angel. Okay. 0.224. There's no units given. Okay, so let's just assume this is in meters. Okay, so that's why this is meters. In the exam, the units will be given. If not, then that's in meters. All right. Yes, the error of latitude and departure is the summation if it's not zero. Okay, so this is immediately the error. And then we're not done. There's also the precision. And precision is LEC over perimeter. We already know what LEC is. Okay, and then to get perimeter, please take the summation of this. What's the answer? No, ito muna. Ito muna. Correct, Raymar. And Colleen. Santa Bernardo. It's 939.46. Okay, please solve. Scientific notation, please. Okay. 2 point. Correct, Raymar and Diego. Cruz. Leonardo. It's 2.171 times 10 raised to negative 4 meters. Okay, that's it. So that's your latitude departure, error, and precision. Okay, do you have any questions for number 1? Please answer in the chat. Okay, now let's move on to the next part. Okay, which is balancing. So of course, we're not just gonna let our errors be there. We have to correct those errors, and we call that balancing latitudes and departures. There's 2 ways to do that. One is using compass rule, the other is using transit rule. So to use compass rule, that's correction in latitude over error in latitude. That's your summation of latitude equals L, which is the length of that side, over perimeter, which is the total summation of the lengths. Okay, and then transit rule. So correction in latitude over error in latitude equals latitude over summation of latitudes. So summation of latitudes would be ignoring the signs. Okay, so you're just gonna get the summation of the values of all of these. Okay, and that's summation of latitude if you're using transit rule. Once again, please remember, if we're required to use transit rule, then to get the summation of latitude and departure, we're gonna ignore all of these signs and then just get the summation of the magnitudes. Okay, and then after choosing or doing compass rule or transit rule, you can also solve for the corrected length, which is just a summation of latitude squared plus departure squared. Okay, so this is already the corrected latitude, corrected departure. And then to get the correct bearing, that's arctangent departure over latitude. Again, these equations stem from the fact that latitude and departure are the x and y components of your line if we plot it on a Cartesian plane. So if we have a line getting its x and y components, there's an error, and then we corrected that error, so we have corrected x and y components. To get the corrected line, that's just applying Pythagorean theorem. So that's why it's latitude squared plus departure squared, and then angle, arctangent, opposite over adjacent. Opposite is your departure, adjacent is your latitude, as you can see here. Okay, so these all just applications of your trigo functions, Pythagorean theorem, vectors, and its components. Okay, so let's have another example. Oh, wait. All right, correction in latitude. That is how much you're gonna add or subtract to your given latitude so that it's correct. Okay, so that's correction in latitude. And then this is also the same for correction in departure. Correction in departure over ED equals L over perimeter. So this is the equation I will use to get the corrections. Again, corrections are the amounts by which we will add or subtract to your given departure and latitude in order to correct or balance your given. And then, pwede pong paulit kung saan i-disregard yung signs ng latitude. Okay. You're going to disregard signs of latitude and departure here when you're doing summation of latitudes and summation of departures. Because if you don't, what you'll get is the error. Okay? And that's not the summation of latitude that we'll use for this equation. So you're going to disregard the sign. So just summation of the values. Only here on summation of latitude and then its corresponding summation of departure. Okay? Any other questions? Does that answer your question? Okay, so what do you mean saying? All right. So here we followed sign convention. So negatives and positives will get negative 0.089. Okay, so that's error in latitude. The summation in latitude, all right, would be disregarding all of these. So just positive 188, positive 152, positive 29, and so on. So you'll get a larger number than this. Okay? Any other questions? Okay, now? Okay. Next. So for us to better understand, let's have example number 2, which is compute for the corrected latitude and departure for the traverse in equation or in example 1. So now we're going to correct this. Okay, so let's do that. Let me remove this. Okay, so I'll call the correction for latitude LC. Again, I'm going to start the computations. Okay, so that is, I'm going to write it down. Correction in latitude. So that's LC over EL equals L over perimeter. So for this example, I'm gonna use compass rule. Okay? Since there wasn't any given on what method I should use. Yeah, there's nothing, so I can just choose. I'm gonna use compass rule. Perimeter. Okay? So to solve for LC, okay, again, this is sample computation for AD. That's L, which is 189.53, over perimeter, which is 939.46 times EL, which is this, your 0.089. Okay, so all I need are the magnitudes of correction. So I'm disregarding the sign here. So 189.53 times 0.089 divided by 939.46, you'll get 0.018. Okay, so I'm going to complete this table doing all of this. You can just compute with me in case I did the computation wrong. Okay, so 0.018, 0.017 for this, 0.019, 0.14, okay, and then 0.016. Oh, okay, so the reason why we're disregarding the sign, okay, is because this is just by how much we are adding or subtracting from your latitude or departure. So that's just the magnitude. Okay. So if we also included the sign, for me, that just makes things more confusing. So this is just the correction by how much. Okay. And then later on, we will analyze whether we have to add or subtract this to our length in order to get the correct, or to our latitude in order to get the correct value. Okay. Later on, I'll show you what I mean. Okay. And then okay, so just disregard the sign for LC because again, all I need from this is the magnitude. Later on, I will decide or analyze rather if it's supposed to be an addition or subtraction to your latitude departure. Okay, so that's all for LC. Now let's do your correction in 013. So DE for LC. Let me check. Okay, 42.39 times 0.089. No, it's 1/4. I already just used all of these values. I didn't store. So 0.01356. Okay. So we're just using all of these as is. We're not using the stored values of this. Okay, so that's why it's just 0.014. Because it's a lot of values to store it in your calculator. Okay, all right, so that's LC. Now I'll have you do DC, correction and departure. Let's start. What's the correction for AD? Again, 3 decimal places. Correct Alyssa and Zalika. 2 points ka na daw. So the next one is Jan. So Lahong Pagalanan. So 0.037. Next, BC. Correct. Kian Jasper. Viernes given. .0. How about CD? Correct. Geyser Maria Pagalanan de la Cruz. Pagalanan de la Cruz. 0.039. How about DE? Correct. Kian Jasper. Viernes given again. Okay. And then finally, how about EA? Sorry, DE. Oh, wait. Tama, EA. No. Correct, Geraldine and Jerome. Gilbuena Lazaro. Lazaro. It's 0.046. Okay. Now that we have that, to get DC, that is just length. So 189.53 times 0.184 over 99.46. So it's the same here. The only difference is instead of using EL, we're using ED. Right? For those who wasn't able to follow how to get direct correction in departure. Okay, so this is only the correction. Now I have to apply it to my latitude and departure in order to balance it or correct it. Okay? So I need the corrected latitude and departure. So let's do that. Let me just extend this again. Okay, so again, I'm going to compute for latitude first, and then later on, I'll have you help with departure. Okay, so corrected. This is now the corrected latitude first. So as you can see here, the summation of latitude is negative. Okay, so let's analyze. Does that mean I have to add or subtract values in order to get it to 0? Because remember, it's supposed to be summation equals 0. Okay, so do I add or subtract our corrections to make it 0? What do you think? Correct. So we're adding. Very good. Kurt, Kian, ta-da. And then, 2 points ka na. So next, correct Diego. Correct, we're adding because it's negative, right? In order to get this to 0, I need more value, so I'm adding. Okay, so that means I'm gonna add negative 188.403 plus 0.018. I'm gonna get negative 188.4385. Okay, so once again, I'm gonna complete this table. Let me know if I made any miscomputations. So next should be negative 152 plus 0.017. That should be negative 152.277. Same thing here, 29 plus this, you're gonna get 29.968. How about this? 139.0014, that's 139.083. And then 171.59 times 0.022. plus. It's 171.612. Right. Now let's try adding all of that. 152.277. 0.311 ba? Okay. Negative 152.294. Oh, it's 277. Negative 152.294. Okay. So it's 1 times 10 raised to 3. So that's close enough. Okay, it should be 0. But since we've rounded off, that's why we didn't get exactly 0. Okay. So this would be 1 times 10, negative 3, 0.00 something. Okay. So that's already close enough. If you want to get very accurate answers, you can try storing all of these in your calculator so that we can get an exact answer of 0. Okay? Yeah. So we can get 0.003, 0.001. That's a small enough value to correct our latitudes and departures. Okay. Again, if you want to get an exact answer of 0, you can try recomputing for this and storing your values instead of using the rounded off version. Okay. But this is already okay. So exam has to be 0. So for the exam, I'm gonna give values so that even though if you round it off, you're still gonna get an answer of 0 without storing. So for this example, we had to store, but it didn't fit the calculator. Yeah. All right, so let's make it a rule for the exam. Let's use the stored value instead. So I'm gonna give enough value so that you can store all of it in your calculator. Okay. So for the exam, use the stored value so that it's uniform answers. All right. So now we have summation of latitude. So please do for departure as well. What is the corrected departure for AB? Correct. KB and Diego. But you're already 2 points. So Maro, Pasokle Escobar. So that's 50. What was that? 20, negative 20.597. What about for BC? Correct. KB, Johanna Escobar de los Santos. De los Santos. That was 86.606. And then, what about CD? Correct, Miguel and Alexandria. And Don Bozo. No, 2 points ka na bro. So, Giselle. Negative 195.46. Next, B. correct. Johanna and Jan. Lahong de los Santos. Auto constant. Jericho. De los Santos. And it was negative 30.547. And then lastly, EA. Correct. And 159. Correct mark, Jan. So Villalobos, Rochelle, Reyes. Villalobos, Reyes. Ano ba? Yep. Okay. Positive 159. 998. Okay, then please take the sum. Or do we get 0? Okay, great. So everyone got 0 here. Okay. Yeah. So this is an example of getting 0 even though we rounded off. So for your exam, for uniformity's sake, I'm gonna require you to store your values in a calculator. Okay? Alright, so that's it for balancing. Now, let's take this further. What if I want to get the corrected bearing? Okay. What if in your exam I required you to do that? So let's try it. Okay. Okay. Bearing. And then again, this is corrected. All right, so to get the corrected bearing, this is the equation. Okay, so let's do bearing first. Arctangent departure over latitude. And you're gonna use the corrected values here. Okay? So I'm gonna give you an example. So for AB, that would be arctangent departure over latitude, right? So departure, the corrected one is 20.597 over 188.385. Okay, arctangent 20.597. You're gonna get 6 degrees, 14 minutes, 22.66 seconds. Now, the sign will depend on the sign of your latitude and departure. Departure is negative, therefore that's south. Latitude is negative, therefore that's west. Okay. So sign again depends on the sign of your corrected latitude and departure. So negative meaning south. And then the answer to this was 6 degrees, 14, 22. So 6 degrees, 14, 22, and west. And that's how you get the bearing. Okay, let's do one more, BC. So again, that is arctangent. 86 divided by 152, you should get 29 degrees. Latitude is negative. Latitude is your north-south. Okay. Latitude is negative, so that's south. And again, the value of arctangent 86 divided by 152, that's 29 degrees. 37 minutes, 4302. Okay, and then this is positive, therefore that's east. Okay. Now let's do CD. What's the bearing of CD? Just give me the angle. Correct, Carlo and Jasper. Okay, since no one else answered. So this is 81 degrees, 15 minutes, 59.77 seconds. And then looking at the sign, positive, so that's north, negative, so that's west. North, west. Okay? And then I'll complete the table. Just try to follow along with me and let me know if I did anything incorrectly. So this should be north, 12, 23, 14, west. And then 42. So north, 42, 59, 38.92 minutes east. Okay? And then the final thing to correct here to complete all of our values is the corrected length. And that's just latitude, square root of latitude squared plus square root of departure squared. So again, let's do line AB. L equals square root of 188.385 squared plus 20.597 squared. We should get 189.508. So this is 189.508. Okay, you do the rest. Please solve what's the corrected length for BC. Correct, Alyssa and Jan, lahong pagalanan. So that was 175, 182. How about CD? Correct, Colleen. Sante. Ano pa? 3, 2, 3. Okay. Angelica. Correct. So Angel. All right. That was 197, 744. How about DE? Correct, Miguel. And Lauren. Silvana Gozo. 142,398. And then lastly, EA. Okay. Correct. Joanna and Kian. Kiban de los Santos. CD. Okay, and then may sumagot ba? No. YouTube. Correct. And then also you too, Micah. Okay. All right. So that was 2, 3, 4. Okay. And that's it. These are your values or should be values for the corrected bearings and lengths of your given values. Okay, so the question only asks for corrected latitude departure. So I also added your corrected bearing and length in case I'm gonna have that in your exam. Okay, so that's number 2. Do you have any questions for number 2? Please answer in the chat. Okay, great. So as you've noticed, this topic is just very computation heavy, addition and multiplication. So due care is needed in completing your tables. Okay, because one mistake will lead to the succeeding answers to be incorrect as well. Okay, so please be careful in doing your latitude departure computations. Okay. So since you don't have questions, let's move on to getting the area of your traverse. So we have 2 methods there. We have DPD and DMD. So DMD is also known as your double meridian distance method. So the process involves the following. First step, the DMD of the first course is equal to the departure of the course. Next, the DMD of any other course is equal to the DMD of the preceding course plus the departure of the preceding course plus the departure of the course itself. So DMD plus previous departure plus current departure. And then just repeat that step until you reach the last side. And then the DMD of the last course is numerically equal to the departure of that course, but with the opposite sign. Later on, I'll show you what that means. And then the area, to get the area, that's just 1/2 times the summation of DMD times latitude. Okay, so that's the DMD method. Next, DPD, also known as your double parallel distance method, involves the following steps. Step number 1, DPD of first course equal to latitude of the course. Number 2, DPD of any other course is equal to the DPD of the preceding course plus latitude of preceding course plus latitude of the course itself. So DPD is equal to previous DPD plus previous latitude plus current latitude. And again, repeat that until you get to the last course or last side. And then the DPD of that last course is numerically equal to the latitude of that course, but with opposite sign. Again, I'll show you what that looks like later. And area is just 1/2 times summation of DPD times departure. So they're almost the same. DMD just involves departures. DPD involves latitudes. Okay. So those are your 2 methods. In order for us to have a better understanding, let's have once again an example. So given the following data shown, find the area of the traverse using DMD method. So this first one. So we're going to look at departures here, right? And then given the following data. Okay. So I'm going to copy that again, so I don't have to write that. Okay. Okay. Number 1, and then this is area of a traverse. All right. So we're using the ND method. Okay. So let's do that. All right. So in order to do that, again, let's follow the steps. Let's first take the double meridian distances with the ND. Okay. So let's look at here. Look at it here. The ND of first is equal to the departure. So let's look. Departure is this, so that's also 32.43. Next. So previous departure plus previous DMD plus current departure. So that would be 32.43 plus 32.43 plus 5.25. And you should get 70.11 and so on and so forth. Now you try and do it. Can anybody give me DMD of side CD? Correct. Alexandria and Micah. Polycarpio Arendon. So that's 48.56. So that was 70.11 plus 5.25 minus 26.8. Okay, next, how about DE? Correct, Carlo and Maro. Florescal, Casople. Florescal, Casople. Oh, yung mga wala pang recitation dyan, it's your chance. There's so many computations. Okay, so correct, that was 17.29. And then EA, finally, what's EA? Correct, Kian and Jasper. So that was Viernes to them. Correctify as well. It's 6.41. Okay. So again, first DMD is just copying the first D departure. Next, 32.43 plus 32.43 plus 5.25. This is what you get. 70.11. Next, for line CD, that's previous DMD. So 70.11 plus 5.25 minus 26.8. You get 48.56. And then now for DE, that's 48.56 minus 26.8 minus 4.47. You get this. And then finally, for EA, 17 minus 4 minus 6, you get this. Okay? Did you get the computation now? Okay. Now look here. You're welcome. Now look here. As you can see, they have the same value, but with opposite signs. And that is what they were talking about here. And the ND of last course is numerically equal to departure, but opposite sign. So equal to departure, but opposite sign. So this is a way for you to check if you did things correctly. You should be able to compute it in a way that your final answer or your final value here or the last row should have the same magnitude as the given departure. Okay? So since it's equal, we did things correctly. Or rather, since they are the same value, we did things correctly. Now the next step, look at our equation. That's summation of DND times latitude. So let's do that. DND times latitude. So 32.43 times 9.2, that is 298.356. Okay, or 36. Now for this instance, I want you to store the values. Okay, so store values. So this isn't just 36, that's 356. Okay, I'm gonna write the entire thing so that it's more obvious that you should store the values. Next, can you compute for DND times latitude of BC? Correct 5. And Jan, Lahom, Fern, Fajardo. And, oh no. And Zaira. Familiar, Fajardo, Lahom. No. Fajardo. Right. That's negative 445,198.5. Okay, so include the sign still. Sign convention still applies. Now what about CD? Correct, correct, Kurt. And KB, Escobar Astadan. That was negative 12976. How about D? Correct, Zaira, Kian, no, dami. Okay, so what did I say? Um, Zaira and Kian. Kiben, Ortiz. Or kami. Yung sunod. Sean. And mali. De Los Santos. Okay. So that was 92.6744. Finally, EA. Correct, Michael and Colleen. Sante Ácido. Sante. Mama din. Sino yun? Also, Maria. Oh, it's positive. It's not negative. So that's Pagalanan. Okay, positive 133.075. Okay, negative. It's this times this, not this. So positive. Okay, now please take the sum of this. What's the answer? Correct. Zaira and Zelika. Angel and Angel. All right, it's negative 1327.4 5H2. So that's the summation of DND times latitude. Now, it's not shown here, but that should be absolute value because this is an area. Area is positive. There's no negative area unless we're talking about integral calculus. Okay, so therefore area is 1/2 absolute value of summation of DND times latitude. Okay, please compute. What's the final answer? That's correct. John de la Cruz RDL. Rapid. Okay. Right, that's positive. Again, because it's absolute value, so positive 663.7291 meters squared. Now in the exam, if I stated that round off your answers, final answers to 2 decimal places, then that's 663.73 meters squared. Okay, and that's it for getting the area using the DMD method. So DPD is basically the same, but instead of using departure, we're using latitude. And then this would be DPD times departure. Okay. So that's it for area of a traverse. Do you have any questions? Please answer in the chat.
None po, ma'am.
Okay, great. And that ends the lecture for today as well. Okay. So do you have any questions? Oh, by the way,
Ma'am, same process lang po sa sa DPD.
yes, same process. But instead of using departure, that would be using latitude, and then this would be DPD times departure. Okay?
Thank you po.
Okay.
Okay po, ma'am.
Oh, I don't check MS Teams. Reminder, for those who haven't, please watch the orientation video. It was mentioned there that the only appropriate way to contact me is through course messages and Blackboard. I don't check anywhere else. Okay, you can also ask me here in Zoom if you want an instant reply. Yeah, okay. So yun lang. For those who haven't watched it, please watch it because most of your questions are answered there. And some reminders. Oh, okay, so assignment 1, my bad. I set the availability date at 11:59 p.m. instead of 12 a.m. That's why you weren't able to see it on Saturday. Because of that, I made an announcement. I moved the deadline of your homework to today, 11:59 p.m. I've already graded those who submitted, so you can still submit until today for those who haven't yet. Again, today, 11:59 p.m. It's up to you if you want to put your reference list, okay, or source list.
Thank you po.
Okay. It's not late if you passed it today because it was my mistake, so I moved it to 11:59 p.m. today. If you were able to pass within today, I will give you your full score. Okay, you won't have any penalty. There's no time limit in taking assignment number 1. Yes, we have activity on Saturday. What was it again? Let me check.
Ma'am, bali next week pa po yung final exam po, di ba?
Yes, next week. And this Saturday we have seat work number 2. So there's no Zoom meeting again. So just answer your seat work that's available the whole day as well. I think you'll have 3 attempts for the seat work. There's no time limit for this as well. And then next Next Saturday. That's your modular exam.
Oh, Saturday. Thank you po.
Okay. Any other questions?
So, bali ma'am, may 1 week kami na bakante? Or,
We have group activity here.
okay, ma'am.
Okay. Next week, group activity. Ano pa? Anything else? Did I miss anything? Yes, exam is from here, the introduction to surveying. Saturday. Exam is on Saturday. So this entire thing is the coverage. Wait. Oh, do you wanna wait? Friday. Is it okay if we do it on Wednesday instead so that I can plot it during your field so that you have more time for your modular exam? Or do you want to have it on Saturday during your lecture? Let me know in the chat. During field, during lecture, your modular exam.
Saturday na lang, ma'am.
I'll take majority.
So ma'am, pag lecture, ma'am, 2 hours lang? 1?
1.5. Yeah, 1.5. If lecture.
4 hours, ma'am.
4 hours.
Pero same pa rin po yung given na mga kuha namin, ma'am.
Yes, it's the same coverage. Whether you choose field or lecture. I can't. Conflict of schedule on Saturday. That's why I cannot extend your hours. I have other classes as well.
Ma'am, may Friday, di ba, ma'am? Ay, kaso lecture. Ano ba yan?
Friday is field, but I also have class at 1
Oh
o'clock.
my.
So that's why I cannot give it to you on Friday. Yes. So your choice is Wednesday, 3 hours. Okay, not 4 hours. 3 hours on Wednesday, or 1.5 hours on Saturday. So Wednesday, 3
Ma'am,
hours. Friday, 1.5. Wed. Okay, majority vote. Wednesday or Saturday. Sagot mo. Okay. 90% Wednesday. Yeah, next Wednesday. Not this Wednesday. Okay, next Wednesday. Okay. All
ma'am,
right.
pero kaya naman sagutan siya ng 1 hour and 30 minutes, ma'am.
Yes, kung dire-diretso ka magsagot. Kaya naman. Right. So since most of you answered Wednesday, I'll give it on Wednesday. Okay, since modular exam is 40% of your grade, so I'll give you that 3 hours. Ilang items? Most likely 20 items objective. And then, so that's your identification, true or false. And then 4 to 5 items for problem solving.
Pwede na, ma'am.
Okay. Wait lang. Other questions? Okay. I'll end the recording here.